is really tricky, right? Okay. I wanted to see if you guys get started. I wanted your workspace because it's a tricky example.
For your points, would it be 2, negative 2, 2, and 0? Or would it just...
Oh, wait.
I think just 0. Did you guys find anything else besides 0?
I don't know. Everything else works except for 0.
Yeah, I think it's just 0. Okay, let's talk about this one. This one's weird, right? It's a piecewise. So you're in your workspace. It's a tricky example. Sometimes I like to put tricky ones in the workspace so you can go look at it because it's like a condensed version. So it's a tricky one. Increasing, decreasing. What's the first thing that we need to check? What's this?
Domain.
Domain. Okay. Technically, the domain is all real numbers because any x less than or equal to 0 will get plugged in here. Any x greater than 0 will get plugged in here. So all x's are allowed to get plugged in. Now look at your pieces. Any denominators, square roots, ln's? No. So all the x's are being included, so the domain's going to be just all real numbers. But when we get to critical numbers, we have to look at the derivative. So when we look at the derivative, kiddos, what's the derivative of the top piece? Remember, piece by piece.
Negative 2x.
Good, negative 2x. What's the derivative of the bottom piece?
Negative 2.
Now here's the dilemma. We know this one's going to be x greater than 0 because that was never equal to 0. Why am I writing x less than 0 but not? Because the derivative, there are two ways to see it. Charlotte's saying because of the derivative. Actually, the problem showed up way before the derivative.
Because there's a continuity break, so
There's a continuity
it's not differentiable, so you can't say it's greater, or it's equal to 0.
Can you explain how you knew there was a continuity break? He's saying it's discontinuous. Not that it doesn't exist, not a
It's a piecewise.
not a domain error, but why is it discontinuous?
It's a piecewise, and when you plug in 0, it's negative.
When you plug in 0 to the top, where are you headed when you come towards 0 from below? Where are you headed? What height? 4 minus 0 is 4. What height are you headed to from above?
0.
So you have basically this guy coming in and going here, and you have this guy coming in and going there. Is the slope of the tangent going to exist? Can a function be differentiable if it's not continuous? Ooh, give me a forever card.
Whoa, continuity.
It's like the characteristics with continuity and differentiability, right?
Whoa, what?
If a function is not continuous, it's not differentiable. So, if it's not continuous, it's not differentiable. Here's another way of looking at it. Charlotte was saying at the derivative, and she's kind of right, but technically sometimes they look like they should match and they don't because there's a break. But if I was to plug 0 into the top piece, what's the derivative, what's the slope supposed to be as I come from below 0? 0. But as I come from the top piece, what's the slope supposed to be? So even if these were right next to each other, it would be a sharp point because the two derivatives don't agree. But they don't necessarily need to be next to each other. I mean, what I mean is, the derivatives, just because they don't equal, doesn't mean like, oh, that's the reason why. That's not necessarily the reason why. The reason why is because it was discontinuous to begin with. Okay? But if it was continuous and we had the derivatives not agreeing, these are two different ways. Sometimes they're both true, the derivatives don't agree as we plug in, and the function doesn't agree, but sometimes only one is true. Any of those are
Then how would you make your number?
able to say not differentiable. Well, hold on. So we know that the derivative does not exist at 0. So our critical number is 0. I think a lot of you guys kind of figured out the 0, but maybe from different ways. Some of you would have set the derivative equal to 0, which happens at 0. But what we need to think about on our number line is that the 0 needs to be included. But the domain is all real numbers besides that. So the number line goes forever to the left and forever to the right. Just the 0 needs to be marked down because it's a discontinuity. Technically, the domain still includes 0 because I can still plug it in. It still has a height. But because there was that jump way up here, it's going to be included in my critical numbers. Okay, so then how does the sign chart work?
Put 0 and determines the
I have to plug in. Good. I have an interval here, which would be negative infinity to 0. I have an interval here, 0 to infinity. I have to plug in a point, but plug into who?
No, it's just like if it's
So you
Yeah,
plug into
plug
the
into the
formula.
derivative, check the positive or negative, which will tell me about what H is doing, the behavior, sorry, what F is doing.
So would you plug into only the negative 2x?
Yes, well, for these ones,
But for
Because
the
it's
right one,
less
would you? So how would you plug into the negative 2?
well, hold on, let's do the left one first. So, guys, if I was to pick -1 or -2 or -3, I'm plugging, David said, like, plug it in the top one, because aren't all of those numbers less than 0?
Yeah.
So plugging in, what's a negative times a negative? Whether it's -1, -5, -10, yeah, those will all be positive. Which means, positive behavior of the F,
Increases.
when the derivative is positive, the function increases. When the rate is positive, the quantity increases. Okay, now, Sean, you're saying the next side. Can you talk it through?
Okay, so we can choose any number. However, we already know that it's just going to be -2.
So no matter what you choose, it'll
Oh,
always be
sure.
-2 because it's a constant, no
Yeah.
x to plug in.
So if it's whatever it's a constant, we already know it's going to be.
We already know exactly.
Whatever it's going to be.
Exactly,
Okay, so it'll be negative.
exactly. And then what's my function doing, everybody, since the rate is negative? It's decreasing.
I love that.
Now, we could say, oh, okay, the function is increasing negative infinity to 0, it's decreasing 0 to infinity, but what do we say about relative extrema?
But
No,
oh,
no
0
relative
can't
extrema.
exist though.
There's no.
So we
Because
like
there is
yeah,
no
relative-
extrema.
No extrema.
No extrema.
Because it's a discontinuity.
Are we supposed to say that there's extra?
Is there a relative extrema x equals 0?
You would think that
No.
there would be a relative max, right? But the problem is, do you remember what our graph looked like? It was like this, and it was like this.
Yes.
Can I take a region around that point and it's the highest on both sides? No.
I mean,
It's not, right, but it's not continuous. So since it's not continuous, I'm going to say no relative extrema.
So is it whenever it's not continuous, there can't be a relative extrema?
Because think you need to have on one branch of the graph, you need to be able to, without a discontinuity, take a vicinity around and have it be the maximum. Since there's that break. Now, would it be an absolute max? Yeah, it would be an absolute max. That'd be great. We just aren't going to call it a relative. We aren't going to call it a relative. Let's get back into our notes. Let's get back into our notes. The AP likes to somehow play with your minds.
A lot.
So as you get your notes out, I want you to read this one and say, huh, what's different? Huh, what's different?
Is that term?
Critical points don't necessarily have to be extrema. Right?
True, but they say find the critical points and then determine if any of them are extrema.
those seem tricky.
So some of them might be like, no, it's not, like a neither or a none. So find all the critical points and then figure out, are any of them extrema? If so, tell us which ones. But yeah, Sean's right, critical numbers don't need to be. Critical numbers don't need to be relative extrema, that's very true.
It's obviously continuous.
I'm double checking something really fast. Have you guys ever had those things where you're like, oh, I know how to do this, and then a second later you're like, wait, don't worry, it's not this problem. But you said you guess yourself, and you're like,
Oh.
I could argue for the other answer too, and then you're like, wait.
Misty, is it because they like factored out? And
Oh, wait, that's
that
F
takes you
prime.
extra long? Oh,
That's
that's
F prime, it's not just F.
I thought it was out.
That's why I'm saying.
We were going down.
So
Right, what's different?
it's F
You're already there.
Integrate, Misty!
Wait, pause,
They're
they
already
did the work for us?
Yes.
They
Sorry.
found the derivative
Wait, are you going to be
for
working
us?
backwards or you just continue from where they're going?
Continue from where you are, because, look, assume
Integrate.
F is,
Continuous everywhere.
oh, so domain is all real numbers, we don't even need to think about the domain, we don't even need to look at the original, all we need to deal with is the derivative, and
Wait, so
we already
in
did
the
it for
task,
us.
did you want us to write, if it's domain, it would be all real numbers?
Yeah,
So negative into.
yeah. Which means no markings in the number line will come from that, right?
Yeah.
Okay.
So you get to start from the derivative, how cool is that? If they give you an
So we're
F
taking
prime, think
1
about it.
6 x to the 6.
Nope, we don't need to take a derivative at all, we get to use him. Go find your critical numbers, set equal to 0.
5
Does that make
thirds
sense?
x to the 3rd. Is that it?
What?
No.
Where's the cube root of plus and minus the cube
Plus
root?
or minus
No,
cube root of 5.
I'm Misty.
0 and plus or minus cube root of 5, right? Because you gotta set both.
Oh, so you got this off this one? Oh, it's
I
zero.
think just positive cube root.
But we don't have a domain problem though. Because when you cube,
Oh, like,
right?
it's negative and you keep it, it's gonna be negative.
If you
Because you
got,
add,
no, Shimi, if you got negative, cube root of 5, you
It's still gonna be negative.
no matter.
still go negative. So this is
So if it's negative times negative becomes positive times another negative.
X to the
negative.
fifth minus 5x squared.
But it's,
Yeah.
why didn't you get cube root?
Yeah, you read.
Cube root
It'd
of
have to
5?
be.
So it's just, so only positive.
Because it's not negative, when you add it over, it becomes
Yeah.
positive.
Have you ever seen the movie Paul?
It's cube root 5.
Because it's cube root.
Because if it's a negative and a negative, it'll be more positive.
Yeah, but you don't, it's not negative.
Not a long
It's
cube,
positive,
Molly.
because you add the
Not a
5
long
over.
cube.
Oh, that's alright. It's only the.
So it is
A long,
cube root
Just
like,
of 5.
I want to see.
you're
But if
coming
you
along,
ever
like,
add a
got a long
root,
cube.
plus or minus the root.
Yeah, but it's cube root, so it's just square.
Yeah,
But
I know that, but does that justify
Did
it?
the math?
I don't know.
That's parrot.
Yeah, pair.
Okay, I haven't seen it.
Yeah,
That's true.
Literally,
if you're making a sign chart, you might as well put it because it won't change anything. You'll still be increasing.
Plus
It
D10.
won't
yes.
change any-
What have you done so far?
Is it cube root of 5? Alright, we'll see. This is class.
Don't we set each one equal to 0?
Yeah.
Okay. So then as we set equal to 0, x squared equal to 0, isn't that just square root both sides, 0? So I have x equals 0, and what am I finding right now?
X equals the cube root.
My crits, right?
The crypts.
Crits.
And I,
So stupid.
Did you say Tupac? No, Sarah.
Sarah's cool.
Sarah, did you enjoy your birthday?
Sarah is not a.
Yeah, Sarah, how do you have a birthday?
It was super.
Oh, that sounds so
Nice,
good.
from where?
This place called Noah's Ark. If that's you're not a.
We have to try that one. Cube root of 5, right?
Yeah.
Yeah.
Because you add 5 equals okay. So what were you guys discussing? What was wrong?
No, I was just wondering if it's plus or minus.
Plus or minus.
Why not?
Because it's not
It's a
square.
cube root.
Did you guys follow what Anna and
Or it's
Charlotte
an-
were saying and the
it's
rest
an
of you guys?
odd
also.
If you put in a negative, it comes out negative. If you put in a positive, it comes out positive. So plus or minus does not result in the same answer. So when I go to take the cube root of a positive, it had to come from a positive. Does that make sense? Because if it was a negative times a negative times
Oh,
a
it's like
negative,
that.
it wouldn't have been a positive 5.
So it's like that absolute value thing, kind of, like how like we're rationalizing that square root too, like the square root, just a square root,
Like when we do this,
and then it has to be absolute value.
a positive plugged in becomes positive, a negative plugged in becomes positive. Yeah, that does equal absolute value, which is why when I go to take a square root, I need to think about x could equal either plus or minus of a number. But if I have a cubed root
It doesn't matter.
of x
It stays the
cubed,
same.
it needs to stay exactly the same. Yeah, so no plus or minus is needed.
But wouldn't it just stay positive anyways? Because when you add the 5 over, it's positive 5?
Yeah, but what Sean's saying is if it was x squared minus 5 equals 0,
Yeah, it's.
remember that we'd have to do the plus or
yeah.
minus. But with a cubed or a fifth
Yeah.
or a seventh, no plus or minus is needed, is even allowed.
Okay.
Yeah. You guys are going with the number line, yeah?
Yeah.
Can anybody tell me why am I having the arrows go forever?
Because it's infinity.
Because
The domain is good. If the domain was ever restricted, I would need to cut it, truncate it, and say, no, he's not allowed to go to negative infinity.
Okay.
I'll show you an example of that hopefully before today is done. You guys do have one in your homework. That it does not go forever.
Cube.
Ooh, okay, hold on. Yesterday, I said, wait a minute, what if you're not allowed to use a calculator for these? How do you visualize? You don't need to know the exact decimal, you just need to have an idea. So cube root of 5,
Cube root of 8.
It's actually 2, right? Yeah.
right? Because we have cube root of 1, which is 1. We have cube root of 8, which is, so it's somewhere between 1 and 2, right? Is that cool?
Yeah.
So then when we go to think about our critical numbers,
So it'd be
The
0.
1.7. That's my guess.
yeah, I can use 1, right? I can use 1. I could even use 2, no, I couldn't use 2. But I could use 1, because it'll be less than. So I'm going to go ahead and plug in, I don't know, what do you guys think? F prime of negative 1?
Yeah.
F prime of 1?
Yeah.
And F prime of 2? Or 3? Or 10? Or 20? Or 152?
Wait, why didn't you say you couldn't use 2?
Oh, I meant for this one. I said, oh, let's use 1, let's use 2. Oh,
Yeah, I got
Miss
you.
D, it is
in between.
1.7, I was right.
So that would be,
what are we plugging into?
The derivative.
The derivative, that's right. So when we go to plug in, some of you guys are going to get way too stressed about getting the actual number, but you don't need to, right? We just need to know the sign. So if I plug into a squared, what's anybody's squared?
positive.
A positive. And then when I plug in -1 cubed minus 5,
It's
Negative.
a negative.
it's a negative. So I know that this one's going to be a positive times a negative?
Negative.
Yeah. You guys keep going with 1 and 2. I'm going to just label my sign chart.
So positive.
Sign of F prime.
It's gonna be
Negative.
positive times a negative.
Well-
So negative.
Negative.
Put it this
And
way.
then
I need you to label it until
positive
it's
times
second
positive.
nature. That you know
Right,
exactly
that's-
what the positives are doing or
That's
saying or
positive,
negatives with the
yeah.
derivative
So it's
and the behavior
decreasing,
with F.
decreasing, increasing.
Yeah.
Cool.
If you want to, guys, once it's like second nature, I want you to label at least the first few of your number lines. But then, after that, couldn't we almost just do F prime and you know it's sign? And then F and you know it's increasing, decreasing?
Why do we have to write sign of prime and behavior about?
Let's put it this way. On the AP, the FRQs, the free response, you have to sometimes give explanations, justifications, write sentences to explain this sign chart. Or sometimes they put wording in multiple choice of words from the sign chart. A lot of kids tend to use as synonyms, English, synonyms, what are
Similar
synonyms?
words.
Similar, yeah, words.
Similar words, well, words with similar meanings, right? Okay. A lot of kids think that increasing and positive are synonymous, but they're not even close. Positive strictly means the value is a positive number. Increasing says, hey, he's changing, moving, behaving in an increasing way. So a lot of kids use the word increasing with a derivative and use positive with F. They mix and match and say, oh, I know the general idea, I'm just going to throw in this word, and they use the wrong one. And then that's when points get docked, or that's when a whole multiple choice is wrong because they thought of it wrong. So what I'm trying to do is to remind you, signs of derivatives, positives, negatives, tell us about behavior of F, increasing, decreasing. So the quantity is increasing, decreasing, the rate is positive or negative. And we have to keep those, that positive and that increasing separate, and that negative and that decreasing separate. Does that make sense? So I'm just trying to train you in that now. Wait,
Increasing,
did you guys plug in?
Yeah, it's negative, negative, positive.
Negative, negative, positive. So decreasing, F is decreasing, F is
So it'd be
increasing.
negative, then you to 0 for decreasing,
Uh-huh.
and then
And we have to split up at 0.
0.
Wait, continuous everywhere. We can actually, if we were doing increasing, decreasing, which relative extrema, it's not exactly what we're doing, but that's okay, let's
Alright.
practice it. Why would I be able to technically say decreasing is from negative infinity to the cube root of 5?
Because it's
Because
decreasing all the way
it's
0.
continuous.
It's always continuous. This isn't a vertical asymptote, not a whole. Now, some of you are like, we should split it up at 0, because it's 0 there, so it's not increasing or decreasing. They say it's at an infinitesimally thin point, so it doesn't even really matter, just make it the entire time strictly monotonic. It's decreasing, decreasing.
Then increasing would be cube root 5 to.
But then, yeah, increasing would be cube root of,
5 to infinity.
good. Now pause. What technically are we looking for though? I mean, that's good, that's part of it. We want relative extrema. So, where's a relative extrema?
Put bam on the right.
Cube root of 5 is a relative who or what?
Minimum.
Follow the flow. Has to be a
Oh,
mesh.
okay,
Follow the
okay.
flow, right? And it's a smooth turn because it's not a DNE, so we know it's gonna. We know it's gonna be a smooth
Wait, so
turn.
you say your relative extrema is at cube root 5 minimum?
Yeah. So we're gonna say a relative min when x equals the cube root of 5. And if they wanted the point, well, let's just say we don't know how to do it quite yet, so we're not doing integration quite yet. Maybe some of you are, but not all of you.
Who's that?
I think one person.
You voted
I was.
Oh, because the derivative was 0, not DNE.
Oh.
Yeah, remember the DNE, or it's not a piecewise function where it's
We used to
not
for
measured.
the second semester integration.
Yeah.
Chapter 4, I think. Is it ever useful for the second derivative sign chart to tell like how the slope?
Section 3.4.
Oh, my.
But 3.3 says the first derivative tells us what? The tangent lines tell us what? Increasing when the quantity or f is increasing or decreasing.
Wait, so what will the second derivative help
The
us?
second derivative tells us,
How the
well, you
slope
ready?
is changing.
Tell us, Miss
Explain it to us, please.
Tell us, Miss D.
Miss D, tell me why I thought you were gonna do a circle and tap on it.
Tangent line is changing over a graph.
Okay, so
Too techy, too techy. Okay, you ready? Here we go.
imagine that we have this,
Second derivative.
and this was on the graph.
If the second derivative is positive,
Just do it.
pause.
That means it's a-
From what you know right this second, you don't know anything, except, or I should say, you don't know anything about what's going on with f. But how could we know something that's going on with f prime?
Isn't that equal to
The
zero?
slope is
Why is f
increasing.
prime increasing? Who is this, the prime?
The rate of
Ah.
change. Oh, yeah. Okay, yeah.
The second derivative is the derivative of f prime.
Okay.
So I can say, well, whenever a derivative is positive, its original is increasing.
Oh, negative.
But you can't tell anything.
Well,
So it's
pause,
from
not
the
that you
second
know yet, I'm gonna show you.
Writing is like.
But the second derivative, right, is the first derivative of who?
The first one.
The first derivative. So I can say, remember, increasing, decreasing test, whenever the derivative is positive, its original is increasing. Does that make sense?
So it's gonna be increasing as well.
The slopes are increasing. Now pause. Let's think about how the slopes could be increasing. Let's say I give you a slope of up 1 over 1. Okay. If it's up 1 over 1 at one point, just give me an example of what it could be at the next point where it would be increasing.
Up
One over one?
No, that's going to be the same.
Up 2 over 1.
Up 2 over 2. So let's say we go, let's say this was like
Up 2
an A.
over 1.
Okay, let's go to B.
Yeah, one already.
Okay.
At B, what if we have it up here somewhere? And let's say it's going, hold on. Let's do a little baby tangent line. Okay, let's say this one is going up 2, no, it's up 2 over 2.
Is it after?
Up
relative
2 over
minimum?
1.
Christy, is it after a relative minimum?
Not necessarily.
So it'll be up 4, up 2.
And then, yeah, we could do up 1, 2, 3, 4 over 1.
Like a cubit?
Do you guys see how this is only going to be possible if the function is concave up?
Yeah, okay, that's what I was referring.
And actually, a better way of showing this, if these are tangent lines, which is what I was trying to say, if these are tangent lines, it wouldn't be going through, it would be skimming, right? So you'd have one
I'm gonna
there,
have a tough time with that.
have one there, have one there.
Close enough.
The tangent lines are increasing for any concave up portion of a graph. Because the slope is somewhat flat, steeper, steeper, steeper. The slopes are increasing of a concave up graph. Now wait a minute, hold on. But there's another side to a concave up graph, right? What about this one? That's
Well,
concave up, and what are my
those are-
slopes doing?
Those are decreasing x
No, they're not.
towards 0, right?
They're getting flatter, but they're
Yeah.
not decreasing, and here's why. What are the signs of the slopes? The function is decreasing. But what are the signs of f prime for this one?
They're really negative. Oh,
So
they're-
wouldn't that
they
mean
are.
this would be a high negative, and a lower negative, and a lower negative, and a lower negative? What's going on a number line if you're going from really negative close to
Close to
0?
zero.
You're increasing. Numerically, you're increasing. The slopes are getting less steep. But numerically, from really negative to 0, you're increasing, and from 0 to positive, you're increasing. As long as you're headed to the right on a number line, the numbers are increasing. So any concave up graph, the derivative or the rates are increasing. So what do we know about f? Now we would need to know if
It's not very helpful.
we would need to know if f prime is positive or negative to know whether it's going to be this part of a concave up or this part of a concave up. Because just from the second derivative being positive, we only know it's concave up. But if we could know what f prime was, then we could know whether it's concave up decreasing portion or whether f is a concave up increasing portion. If we put the two together, we know exactly what kind of curve it's going to have there. So question, what do you think is going to happen if my second derivative is negative? Good. F prime is decreasing.
Should be concave down.
Exactly. Just from like, there's a pattern, right? You're like, oh, I think it's going to be concave down, but let's look at it real quick. If I have concave down an increasing portion, which I would have to know what f prime sign is, or concave down a decreasing portion, think about the slopes. Let's go positive. Our numbers or our minds think better positive. Really positive, less positive, less positive. Do you see the slopes decreasing?
Yeah.
Okay, a positive number getting lower. That's going to be moving this way on the number line. Positive numbers towards 0. But what's going on here? Almost 0, but
Is one more
what's...
negative?
So think a number line. If you're at 0 going negative, aren't you still decreasing? Now, the absolute value, the speed could be increasing because you're going negative faster and faster, or you're going faster and faster in the negative direction. But for our purposes, numerically, the tangents are decreasing. Slopes of the tangents. Guess what? That's 3.4. In a nutshell.
Alright, let's skip it. Go to 3.5.
AP likes to make things tricky. Let's take another one.
This is notes.
Yep, still 3.3. You guys asked, so I delivered. Period 6, I just have to remember to deliver there as well.
That's not too bad. I mean,
Like, you can kind of see it.
I think it's easier to see it in the number.
Yeah, the hard part is thinking a number line and saying, wait a minute, it's getting less steep. But you have to realize that it's getting less steep. Negatives coming towards 0, that's an increase.
Positive if it's vertical.
The graph of f is shown. Ooh,
So it starts off positive.
sketch the graph of a derivative. Now, technically, you guys got a 1 up. Because we just talked about concavity and how f prime moves based on concavity.
Is
Really?
it an absolute? No.
It's a cubic.
It's not decreasing at first, the
That looks like
slopes.
an
But the
absolute
derivative
value
will
of that.
eventually be decreasing.
Oh, well, the slopes are always positive, right?
The slopes are, do you guys notice that the slopes are always positive?
Square's an
So
absolute.
that means that
value.
the derivative values, y values need to always be above. So let's write things down. You know, f prime, y equals f prime, because we're graphing a y equals. Will be always positive.
It's 1/3 squared.
We can also be kind of snazzy. We can also be kind of snazzy, and we could, eventually as we learn more, could actually make a sign chart. And it's technically an increasing, decreasing sign chart.
Why is it?
Behavior of f.
Why is it second derivative?
Because
Because of
then if you know the behavior,
If I know the sign of f double prime, it'll tell me the behavior of f prime. Not only do I know f prime is always positive, but I can also know where f prime is increasing or decreasing based on f double prime's sign. Now the struggle is we can't look at f double prime, but we can say, wait. F double prime is positive when f is concave up. Where is this graph concave up? From negative infinity to 0, right? So I can say, well, concave up means this sign will be positive, which we're still going to learn at 3.4, sorry, we're looking ahead. What's f prime going to be doing then?
it's going to be going wrong.
So think about it. Is this a really flat, like 0-ish, getting higher and higher and higher, more positive?
Yeah.
Yes. Ooh, how steep does it go?
To VA.
Vertical.
Like vertical, it goes vertical.
It goes vertical, which means it's going steeper, take tinier steps, steeper.
Or is it
Ooh.
V8 too?
So it's going to be doing something like this.
That's what I was struck.
Because there's a vertical tangent line, an undefined slope, which means it's getting steeper to infinity.
And then it's going to go from steep.
Yeah, vertical asymptote. So we could say that not only is f prime always positive, he also has a VA because of the vertical tangent line at x equals 0. And what's the concavity after? Which means the second derivative is
Wait, why would it, the VA at x equals 0?
oh, because that's where the vertical tangent line is, and a vertical tangent line, back in the olden days, when you guys were itty bitty kids, you learned the slope is undefined. But what that actually means is the slope is infinite. So as a mountain gets closer and closer and closer to being a sheer cliff, your chances of surviving get lower and lower.
Until they're infinitely small.
Until they're infinitely small, there you go. But long story short, think of it. If I ask you to graph a line like on a paper of a slope of 5, up 5 over 1. How about 100? Up 100 over 1. That's like, right? Up 1,000 over 1. That's like
Up infinity.
up 1,000,000 over 1. Right? It's getting closer and closer as, okay, it's just going to get steeper and steeper for forever. Now, pause. Concave down. Over here. Concave down. Function's concave down when second derivative is
Less than 0.
negative. Good. You got to attach the greater than less than to negative and positive. Negative, which means f prime is doing what?
Going down. Decrease.
Can we visualize that? Tangent lines. Starting from technically infinity, what's going on to those slopes? Positive numbers getting less and less positive. If you're on a number line, you're at a positive number, and if it's getting closer to 0, what are your numbers doing?
The numbers are decreasing.
Decreasing. If you're at a positive number, going towards 0, positive number going towards 0, you're decreasing. Good. Which means, oh, well, come from infinity, I can't, but I can skim, and go towards 0. Cool. Wait, why is it never hitting 0? Well, does this ever... Let it turn on. I think that'll work. We'll see if it works. So guys, do we get the graph of that prime?
Yeah.
What do we have to think about? All sorts of things. It's sine. All the slopes are positive, so we're like, okay, cool. We have to have all of our y values be above. If y values went below, those would be negative derivatives, which means I had to have had a decreasing portion of the graph. So since f was always increasing, the f prime was always positive, and the concavity told me what f prime was doing as far as going up or going down, and the vertical tangent line told me a vertical asymptote, which helped me know, oh, skim it, and then, oh, skim it. And then do you see how it's getting flatter?
Mm-hmm.
Isn't that why the derivative is getting closer to 0?
Yeah.
Do you see how this one's getting flatter? Isn't that why the derivative is getting closer to 0? The tangents, the slopes are getting closer to 0 as the f flattens. Great job. That was rough. That's a great rough AP problem. So what's different in this one? What did it give you?
They'll give you that time.
It gave you f prime. And we're trying to, wait, are we trying to graph backwards to f or forwards to f double prime?
We're going backwards.
Backwards.
So you guys
Backwards.
see when it's
But
increasing.
isn't that just how we've been
Now,
doing?
pause. I want you guys pause. This idea. Huge. This idea huge. Get out a highlighter. This idea is huge. We'll talk about it more, but this idea is huge. Get out a highlighter for this little star by this.
Copy this one down.
Yeah. Copy this one down, sketching the graphs.
Wait, so
You don't
is it,
necessarily need to write all this, but I do need you to write f prime and f prime, and then get your AB.
are they each different ones?
Yeah, two separate graphs entirely. We're going to do what they ask for 1. Totally separate, do what they ask for number 2. If we can learn, if we can practice, if we can master how to read a graph of a derivative, visualizing the original, which we can't fully do now until we learn integration, but we can do a lot right now. We can grasp how to look at a derivative graph and consider or figure out stuff about f or about the original. That's almost always an FRQ, 1 out of 6. Almost always an FRQ. 1 out of 6 of the wrong answers on the APs. But it's hard. Just because something's hard doesn't mean we fade away. Doesn't mean we chicken out. It means we dig in, right?
Okay, we can find those.
Here we get switch the graphs. And label both of them F prime. Ooh, I think it's strong today, didn't it?
That was pretty good actually.
It was organic, it's good coffee, but it was strong, I'm sorry, yeah.
If two points would be where the absolute max is, like on the second graph,
Of
yeah,
the derivative?
yeah, or of like a function like that is.
Yeah, but of the
there-
derivative, just making sure you have it attached. Okay.
Yeah, like, I guess that would come from like a plus or minus or something.
There would be
but-
changes in signs on a sign chart, yeah.
Yeah, but
Yeah.
like, is there no absolute max, or like?
Well, if you were
There's
looking
two
at, well,
absolute
okay, if the
max.
question was find the absolute max of the rate, or find the absolute max of the derivative, there would be an absolute max of the derivative, not of f, we're in trouble if you're looking at f. But of f prime, the absolute max would be at both points.
Okay.
But there's only one absolute max value of 3.75 or something like that. But it would be at two different places. Does that make sense? So if during a day it gets really hot and gets up to like 92, not really hot like summer, but really hot like fall, 92, and then it goes down for a little bit, gets cooler, and then it spikes back up again. It could have been the maximum temperature of 92 2 or 3 or 4 or 10 different times during the day, but the absolute max is still 92. Does that make sense? Okay, ready? Tyler brought up a really good point. He said, if there are two different, now he's looking at this one, but doesn't this one have two different relative extrema too? One min, one max. This one has, okay. If the derivative, well, if any function, if anything given to me has multiple relative extrema, we could look at a sign chart for this function. If we looked at a sign chart of this function, okay, let's see what we can figure out. So look at the sign chart of this function, which is going to be a little weird because I'm going to be looking at the behavior. Who is this guy?
Oh,
F prime, right?
Yeah. Inside
Okay. Yeah. So that on top, I could figure out from the sign chart, from the increasing, decreasing of this guy, I could figure out F double prime stuff, I suppose. Kiddos, what would be the critical numbers of F prime? Negative? Well, I think it's like negative 1 point,
Yeah,
negative
something like
0.75. Let's do, negative 1's here though. Let's do like negative 3/4. Right, because it'd be like a little bit below 1. 1 is I think where it
I
hits.
saw 200.
Oh,
Or just
yeah.
different.
And then this one would be 0.35, or sorry, 0.75, which would be 3/4.
Should we
Those
do
would be the horizontal tangent lines.
Should we do that number line?
Yeah, you can. What is F prime doing before negative 3/4?
It's
Decreasing. So since he's decreasing, what can I say about F double prime?
It's decreasing, it's less than.
Less than. Negative, right? If F prime is decreasing, which it is, that means that his derivative,
The second derivative, we're not doing the.
it's like Mr. Hart right there, his derivative, I don't know how he does it, he just does that for me. Anyway. Decreasing, well, he runs the New York Marathon, I have full respect. Decreasing, negative, right? Okay. So, question, what's going on in between negative 3/4 and 3/4? F prime is increasing, careful, always attach a subject. You guys know what I mean, subject, verb, whatever, for a sentence. Always attach a subject. The derivative is increasing, which means second derivative is, and then the derivative, which means,
Decreasing.
now,
But why did we do all the second derivative if we want to go to?
dilemma, what does the second derivative tell us about the original?
Oh, that might be pretty good.
Well, okay, so I guess I can say, this one's gonna be concave down, and then he's gonna be concave up, and then he's gonna be concave down. But if I know something about a concave down, do I know what kind of concave down he is? Whether he's concave down increasing or decreasing? Do I know what kind of concave up? Well, stink. I mean, if it's concave down, I'm assuming maybe there's a max, and then concave up, maybe there's a min, and then concave down, maybe there's a max, but where? Not here. This is in between concavity, and guys, when you switch from concave down to concave up, that's not a max or min. So the struggle is we do know concavity, we do know something, but to find things like, hold on, what does the little say? Identify, we didn't necessarily want the critical numbers of f. We wanted the of f prime. We wanted the critical numbers of who?
Those are just the zeros, but
Of f. So, okay, let's think of a different sign chart. This is a sign chart. This is technically a section 3.4 sign chart. Let's think of instead an original sign chart where I need to figure out the sign of f prime, right? Using the critical numbers, the critical numbers of f to figure out the behavior of f. Now pause. Critical numbers are, right? Critical numbers are when f prime equals 0. So I don't want to figure out where the slopes of the tangent lines are 0. I want to figure out when critical numbers of f is when f prime equals 0. And if this is f prime, that's when y equals 0. This is y equals f prime. I want to know when y equals 0 because that's going to tell me the critical numbers to put in here. So I need to say, well, hold on. The derivative has x-intercepts. The derivative has x-intercepts at the critical numbers of f.
yeah.
So, does it make sense the critical numbers come from when the derivative is 0? The derivative is 0 at the x-intercepts, or when the y's equal 0. So, question, when does the derivative graph hit the x-axis? Do you guys show it on yours?
Negative 1.
Negative 1, 0, and 1.
Oh, okay. Break it down.
Because that is when f prime equals 0. We're not looking at slopes. We're not looking at tangent lines. We have y values that symbolize what the slopes were. So I want to know when f prime hits the axis. Now, kiddos, sine of f prime, y equals f prime, I want to know before negative 1, on this portion, yes, f prime is decreasing, but remember, that tells us concavity. I don't want to know that. Not the decreasing, but where it is. Where is f prime? What kinds of y values are going on before negative 1? Where are the y's? The y's are positive. The y's are above. So if the y's are positive, that means that the derivative is positive. If the y's are positive, that means the derivative is positive. So look at the y values. Guys, we always know if you're graphing like a positive y, aren't you going up in a coordinate axis? And negative y goes down? So if the y's are up, then it's positive. The derivative is positive. What about if the y's, what happens after negative 1? Where do the y's go?
0.
Below. It hits 0 at negative 1, and where are the y's after that? Negative. Where are the y's in between 0 and 1? Above. And where are the y's after 1?
Negative.
Now I can say. Oh, from the above and the below of the derivative, what's f doing?
It's increasing.
Increasing.
Juggling there.
F is increasing, decreasing, increasing, decreasing. If you notice, there's my concave down, concave up, concave down, like I figured out.
Oh.
But question, they're asking for critical numbers. Okay, the critical numbers
Negative 1, 0.
are at x equals negative 1, 0, 1. Pause. Relative extrema, what do I got? Relative
Negative 1 in here.
max at negative 1 and 1. And what's going on at 0?
Relative.
Relative. Kiddos, this is where homework gets a little weird and AP-ish. I don't even know if I gave you any. I might have just reduced it to you in class. The point of section 3.3 is increasing, decreasing relative mins and maxes from sign charts. Okay, just go practice. Careful with your derivatives and pause. If it's an even, and you're not sure if you have the derivative right, you don't want to do all the work and have it wrong. Can't you go to Wolfram Alpha and say derive this and check and make sure you have it right first?
Yes.
Yeah. What can you tell